It's my pleasure to introduce AeroShield materials, where our super insulating materials are providing a step change in solar thermal performance. For the Solar Prize, we have partnered with AeroShield, whose engineers have over 40 years of experience designing and installing solar thermal systems. The US has made huge strides adding more renewable electricity generation to the grid, now 20% and growing. But what about thermal energy, which is just as big, is just 10% renewables, and has been stagnant for a decade? Manufacturing facilities use huge amounts of hot water and steam to do everything from pasteurized milk to crack hydrocarbons. Over $40 billion is spent in the US each year to burn fossil fuels to heat these systems. How can we get deployable, renewable energy to the manufacturing sector? Could we electrify it? Well, if we did, we would need full boiler retrofit, and top-of-the-line PV panels would provide 20 to 25% efficiency. AeroShield's super insulating transparent aerogels enable the direct conversion of sunlight into heat at up to 60% efficiency, can tie into existing boiler systems, and as a bonus, thermal storage to support the system can be 90% cheaper than battery storage. Unfortunately, the US has fallen behind when it comes to solar thermal. The US has less than 4% of the global installed solar thermal capacity, but there's a recognition that this needs to change. The Renewable Thermal Collaborative is a consortium of some of the largest manufacturers who have set the goal of reducing thermal emissions 30% by 2030 by installing renewable thermal infrastructure. CEDO's latest 5-year plan included a new priority area, reducing industrial emissions using solar thermal technology. It's clear that now is the time to re-energize solar thermal in the US, and AeroShield can be the catalyst for this growth. So how does AeroShield work? The working principle of solar thermal is quite simple. An object left in the sun will get hot. But as that object heats up, you get thermal losses that hurt your efficiency. At the collector surface, you need a material that allows light to pass, but no thermal energy to escape. What you need is transparent insulation. To explain how we did that is AeroShield's founder and CEO, Dr. Elise Strobach.
Silica aerogels are some of the most lightweight, insulating materials in the world. But it wasn't until my PhD work at MIT that we first understood how to make them truly transparent. And since that key breakthrough, we've begun demonstrating the stability and performance through prototypes made during the American-made Solar Prize and through modeling with Sandia National Labs, showing aerogel can increase the performance of flat plate collectors by 30%.
The voucher work with Sandia National Labs allowed us to complete detailed modeling of an AeroShield insulated collector.
I recently completed the analysis of the AeroShield flat plate collector system, and I was surprised to find that it was able to operate at temperatures above 120 degrees Celsius at 48% efficiency without the need for concentrating the solar resource. This is surprising because typical flat plate collectors can only operate around 80 degrees Celsius. And with these higher temperatures, I think that AeroShield's technology opens up a lot of process heat use cases. My analysis showed that the system could provide distributed rooftop thermal energy with storage at 120 degrees Celsius for an LCOE of 9 to 10 cents per kilowatt hour. This would be cost competitive with facilities utilizing fuel oil or diesel, even before incentives or a carbon tax. And the efficiency and LCOE would only improve with lower temperatures.
In a 2021 NREL report, authors found that $650 million per year is spent on fuel oil and diesel to produce industrial process heat at less than 90 C, lower than AeroShield's target temperature. This would represent 150,000 large systems, enough to keep us busy for many, many years. One user of diesel for heating is the military's remote installations. AeroShield has a letter of recommendation from the Chief Innovation Officer at the Air Force Research Lab and has been recommended for contract for a $50,000 Phase 1 SBIR to investigate solar thermal for showers, cooking, and medical sterilization at remote locations. To help turn our insulation into a real system, we are incredibly excited to announce Alternate Energy Technologies as AeroShield's pilot partner for the American-made Solar Prize.
I'm excited to share AET's plan to build prototypes incorporating AeroShield's technology. My father was the founder of AET and built a strong foundation allowing us to manufacture in the US for over 45 years. As part of the American-made Solar Prize, we are committed to purchasing aerogels to make prototypes, providing AET's MSC40 collectors for retrofit, and providing a test site to evaluate performance in real-world conditions. Innovations like AeroShield have the chance to re-energize U.S. solar thermal manufacturing, and we're excited to see what this high-performance collector can do for AET.
This is just one application in AeroShield's roadmap to becoming a B2B manufacturing company providing transparent insulation. Testing has shown that tiling smaller samples has negligible effects on solar thermal performance, making it a great first market while we scale up to window sizes. When we first applied to the Solar Prize less than a year ago, we were a team of 3 making 4-inch discs on benchtop equipment. Today, we are a team of 7 who have successfully commissioned a pilot vessel that dramatically increased our throughput, will allow us to scale to 5-foot sheets, and will help prove our economics. We've gone from academic papers showing the theoretical potential to a 6-square-foot prototype using anti-reflective glazing generously provided by Guardian Glass, hooked up to heat exchangers simulating process conditions and tested in Florida. We've made a CFD model of our system so we can test new configurations, developed a mechanical mock-up of a 50-kilowatt system with a full bill of materials, and are working with Thermovent to develop an innovative oscillating heat pipe absorber plate that could further improve system performance. While we've come a long way, there is still work to do. With funding from GO, we would have a full-scale prototypes with AET installed on their site in 2022 to heat hot water for their facility. In 2023, we'll continue to optimize our manufacturing processes while we certify products with the goal of 2024 launching our first commercial production line. Our team is incredibly excited about the future of solar thermal. We have brought in expert advisors from aerogel manufacturing, glazing, and heat transport to make AeroShield a reality, and we hope that you will be there with us.